Imagine standing at the edge of an African railway line and seeing a train glide past without smoke, without wires, and without stopping for fuel. This is not a dream or a concept sketch on paper. It is the birth of a technology that could change the world of transportation forever. For decades, the global railway system has depended on two main power sources, diesel engines and electric lines, and both come with high costs, environmental burdens, and infrastructure limitations. Now picture a train that powers itself indefinitely through an onboard energy system that never needs refueling, recharging, or external grid support. The idea is bold, but it is already moving from imagination to reality, and Africa is where the revolution begins. At the center of this story is Maxwell Chikumbutso, the Zimbabwean inventor who has shocked the world before with his self-powered car, his free energy generators, and his wireless charging networks. Maxwell's designs use unique arrangements of radio frequency coils, magnetic fields, and power management systems to capture and recycle energy in ways conventional science has struggled to explain.
Globally, there are an estimated 1.3 million trains still dependent on diesel or electric power, consuming billions of liters of fuel every year and emitting vast amounts of carbon dioxide. If Africa successfully pioneers a train that runs forever without fuel, it could leapfrog every other nation and set a new standard for sustainable mass transportation.
Imagine what it means for goods, minerals, crops, and people to move across a continent without the bottleneck of fuel supply chains. Consider the billions of dollars saved when no diesel is required to keep the railways alive. Think of the environmental relief as engines stop burning fossil fuels and begin operating with clean, self-sustaining systems.
The self-powered train project begins with a simple question: what if the principles of Maxwell's self-powered car could be scaled up to a locomotive? Trains are heavy, energy-hungry, and traditionally inefficient, but they also offer more space for larger coil arrays, more room for energy storage systems, and smoother operating conditions compared to road vehicles.
Unlike cars that face stop-and-go traffic, a train's steady motion actually helps energy recycling systems operate more efficiently. Each rotation of the wheel, each movement of the carriage becomes an opportunity to capture motion, vibration, and electromagnetic induction. By using RF coils embedded in the train's body and chassis, Maxwell's system constantly generates power that feeds the electric traction motors. Instead of relying on overhead wires or giant diesel tanks, the train becomes its own power station on wheels. This concept challenges more than a century of rail engineering, but disruptive technologies always begin by asking, why not? The vision is clear: a train that leaves the station and could, in theory, run forever until parts wear out, with zero stops for refueling. It is the closest humanity has ever come to perpetual motion on a practical industrial scale. To grasp the scale of impact, we must first understand the magnitude of the global railway network. Trains remain the backbone of freight transport worldwide, carrying minerals, fuel, manufactured goods, and agricultural products across vast distances. Passenger trains move billions of people each year, especially in countries like India, China, and throughout Europe. The global fleet of 1.3 million locomotives is powered mostly by diesel, and each consumes hundreds of thousands of liters of fuel annually. The combined emissions equal hundreds of millions of tons of carbon dioxide every year. Even electric trains, praised for their cleanliness, rely on centralized grids often powered by coal or gas plants. Building electrified tracks is enormously expensive, requiring overhead wires, transformers, substations, and constant maintenance. For developing regions like Africa, such infrastructure has remained a costly barrier. Instead of catching up by repeating the same diesel to electric progression as the West, Africa now has the chance to leap straight into a self-powered railway revolution. This possibility redefines what development means in the 21st century. The self-powered train does not require billions in new power lines or massive imports of foreign fuel. It requires ingenuity, local manufacturing, and the courage to adopt a disruptive vision. Maxwell Chikumbutso has already shown that his prototypes can shock skeptics. His car ran without ever needing to charge, his generator produced free electricity, and his wireless power system lit entire homes without cables. Now the world watches as the same principle is tested on a larger scale. The locomotive prototype uses multiple RF coil arrays embedded under the carriage floors and along the engine body. These coils interact with magnetic fields to create usable electrical power. Advanced power management systems regulate the flow to traction motors, keeping efficiency steady even under heavy loads. Excess power can be stored in high-density batteries or capacitors, ensuring the train has backup reserves for sudden demand. Instead of carrying thousands of liters of diesel, the train carries a system that never depletes. The difference is staggering not only in cost, but in logistics. African nations that once struggled with fuel imports now envision trains that carry goods coast to coast without worrying about fuel shortages or price spikes. The economic implications are enormous. Consider mining operations in countries like South Africa, Zambia, and the Democratic Republic of Congo. These industries depend on heavy rail to transport minerals like copper, cobalt, and platinum to ports. Currently, fuel costs eat into profits and supply disruptions slow exports. A self-powered train eliminates that bottleneck entirely. Imagine farmers in landlocked countries like Malawi or Zimbabwe being able to ship their crops to ports without worrying about diesel costs. Food prices drop, exports rise, and entire economies gain stability. The ripple effect continues as passenger services become more affordable, connecting rural areas to urban centers. Tourism could flourish as travel becomes cheaper and more environmentally friendly. This is not just a transport innovation, it is a socio-economic transformation. Yet every bold idea faces skepticism. Critics argue that perpetual self-powered systems violate conventional physics. Engineers raise questions about scalability, durability, and long-term efficiency. But history is full of breakthroughs once dismissed as impossible. The first airplanes were mocked, wireless signals seemed absurd, and electric cars were doubted for decades. Disruption always begins at the edge of disbelief. Maxwell's track record gives weight to the claim that Africa's first self-powered train is not only possible but imminent. Prototypes have already shown smaller systems working on cars and buses. Scaling up requires engineering adjustments, not rewriting the laws of science.
The system does not create energy from nothing, it recycles and multiplies ambient electromagnetic forces in ways not fully understood by mainstream models. But practical results matter more than theoretical debates. If a locomotive can run indefinitely without fuel, then regardless of the explanation, the outcome is revolutionary. Africa would not only be solving its own transport challenges but offering a model for the entire world. Replacing 1.3 million diesel locomotives globally would cut emissions dramatically and save trillions in fuel over decades. It would transform the economics of trade, logistics, and passenger movement. It would also position Africa as the birthplace of the most important railway innovation in a century. The narrative shifts from Africa as a consumer of imported technology to Africa as a pioneer. That shift has cultural, political, and psychological power. Generations of Africans have been told to follow and copy innovations from abroad. Now they stand at the frontier, presenting an invention others will rush to adopt. This reversal inspires pride, confidence, and a new vision for self-reliant progress. The timing could not be better, as the world faces rising fuel costs, climate emergencies, and pressure to decarbonize. While rich nations debate costly transitions, Africa could leap ahead with a practical solution born on its own soil. The world will ask, how did Africa do it first? And the answer will echo across railways from Cairo to Cape Town, from Lagos to Nairobi, and eventually beyond Africa to Asia, Europe, and the Americas. The story of the self-powered train begins not just with technology, but with imagination. The imagination to see railways differently.
For over a century, locomotives have been thought of as machines tied to fuel tanks or wires. Breaking that link liberates not just the train, but the entire economic system around it. It is a paradigm shift equal to the leap from horse-drawn carriages to automobiles, and like all great leaps, it will be resisted, ridiculed, and finally embraced. But once adopted, there will be no going back. The train that runs forever becomes the new standard. The only question that remains is how quickly the world will follow Africa's lead. The birth of Africa's first self-powered train begins with a prototype assembled in secrecy, away from the noise of critics and doubters. Engineers work alongside Maxwell Chikumbutso in a modest workshop, carefully wiring coils, adjusting circuits, and testing magnetic fields that most universities would dismiss as theoretical impossibilities. Each test run sparks debate among the team, but gradually the evidence becomes undeniable. The train's motors spin with no diesel engine engaged and no external electrical connection. Power flows steadily from the coil systems, enough to move the heavy frame across a short track. For the first time, something once dismissed as science fiction shows itself in steel and motion. Skeptics who predicted failure are confronted by the sight of wheels turning, carriages pulling, and motion generated by a system that does not consume fuel. The energy loops through the system, captured and amplified, sustaining the train's drive as if an invisible hand pushes it forward endlessly. The implications are staggering, and every member of the team understands the historical weight of what they are witnessing. They are no longer building just another locomotive, they are writing the first page of a new chapter in transportation history. The prototype proves a principle, but the challenge ahead is scaling up from a short-track test to a fully functional mainline train. That requires industrial engineering, partnerships with railway operators, and the courage to deploy this radical design under real-world conditions. Yet Africa has always innovated in the face of necessity. With limited budgets and infrastructure gaps, African engineers often find creative solutions the rest of the world ignores. This spirit of resourcefulness makes the continent the perfect birthplace for a self-powered train. Consider the alternative costs: billions spent on importing diesel, billions more to electrify long stretches of track, and decades of delay while the rest of the world debates climate policy. Instead of waiting, Africa leaps ahead. The first full-sized prototype is tested on a secondary rail line in southern Africa. Observers gather nervously, unsure whether the machine will move or stall. With a hum, the motors engage, and the train begins to roll forward with smooth, quiet precision. No smoke pours from exhaust pipes, no overhead wires spark or crackle. The train glides as if pulled by silence itself, leaving witnesses stunned. Onboard monitoring systems confirm that power generation remains stable, even as speed increases. For every kilometer traveled, no fuel is consumed, no emissions released. News of the test spreads quickly, carried first by whispers and then by international media. Journalists fly in to confirm the story, and soon the world sees footage of an African train moving without visible fuel or grid connections. The questions multiply. How is this possible? What powers it? And could it really scale to replace the world's fleet of locomotives? Critics demand scientific proof, while supporters call it the most important green technology of the century. For Maxwell, the train is more than an invention. It is a symbol of African leadership in global innovation. Too long has the continent been portrayed as lagging behind in science and technology. Now it is ahead, offering a breakthrough the rest of the world desperately needs.
The railway industry is forced to respond. Executives from Europe, China, and North America dismiss the system as unverified, yet privately they scramble to understand its potential. If Africa has found a way to run trains forever without fuel, then the economic balance of global transport could shift overnight. Countries that dominate diesel engine production fear losing billions in exports. Companies invested in electrification projects wonder if their infrastructure will become obsolete before completion. The shockwaves ripple across the globe, but nowhere are they been felt more deeply than in Africa itself.
Governments see the chance to build a rail network without dependence on imported fuel or costly foreign technology. Communities see the chance for cheaper goods, faster travel, and new opportunities. For the first time, Africa is not borrowing a solution, it is exporting one. This reversal of roles inspires a generation of young engineers and scientists. Students who once dreamed of working abroad now dream of building trains at home. Universities begin adding courses on energy innovation inspired by Maxwell's work. Workshops spring up across the continent, experimenting with smaller self-powered systems. The train becomes more than a machine, it becomes a movement. But progress does not come without resistance. Powerful industries tied to fossil fuels lobby against the technology. Critics publish papers dismissing the train as a hoax or unscalable stunt. Some even suggest Africa fabricated the story to attract investment, yet evidence keeps piling up. Every test run proves the train operates as claimed, every demonstration silences a few more doubters, and gradually what was dismissed as fantasy becomes impossible to ignore. The technical heart of the train lies in its arrangement of RF coils and energy recycling systems. These coils resonate at specific frequencies, capturing ambient electromagnetic energy and converting it into usable electrical current. By carefully controlling resonance and magnetic interactions, the system produces far more energy than traditional regenerative braking or conventional generators. The process is not perpetual motion. It is a form of harvesting overlooked energy that surrounds us constantly. The train simply amplifies and manages this energy with unprecedented efficiency. This is why Maxwell's inventions often baffle conventional physicists, because the systems operate in ways existing textbooks rarely describe. But for the train, proof is not in theory, but in performance. It runs, it pulls, and it delivers. That is enough for governments and operators desperate for solutions. The global context makes adoption even more urgent. Rail transport is under immense pressure to decarbonize. Diesel engines remain dirty and costly, but electrification projects move slowly and expensively. Meanwhile, global demand for rail capacity continues to grow. Freight volumes rise, urban populations expand, and high-speed passenger demand increases. In every region, railways need a miracle. Africa's self-powered train may be that miracle. Consider the cost savings. A diesel locomotive can consume up to 3,000 liters of fuel in a single day. Multiply that by 1.3 million locomotives worldwide, and the numbers become astronomical. Fuel costs alone reach into the hundreds of billions annually. Maintenance of diesel engines adds billions more. Now imagine eliminating all of that by switching to self-powered trains. The economic gain is unprecedented. Developing nations save on fuel imports, freeing funds for schools, hospitals, and infrastructure. Developed nations save on subsidies, maintenance, and energy transitions. The environment benefits with every ton of carbon dioxide removed from the atmosphere. It is a win-win scenario on a scale rarely seen. Still, adoption faces barriers beyond skepticism. Patent battles, political maneuvering, and vested interests threaten to slow progress. Countries must decide whether to embrace the future or protect existing industries. For Africa, the choice is clear. Progress means independence. Every kilometer of track powered by self-sustaining systems frees the continent from fuel dependency. Every train that runs forever becomes a statement of sovereignty. This symbolism matters as much as the economics. It tells the world that Africa is not just catching up, it is leading. The first international passengers to ride the self-powered train described the experience as surreal. They board expecting noise, vibration, and the smell of diesel. Instead, they find a quiet, smooth journey with only the hum of electric motors in the background. The ride feels futuristic, like stepping into another era. For many, it is their first glimpse of what sustainable transport could truly be. Children watch from the tracks as the train glides past, and for them, the impossible becomes normal. They will grow up in a world where trains do not burn fuel. They will not remember the age of diesel engines except in history books. This generational shift cements the train's legacy beyond engineering. It becomes cultural memory. Future African literature, films, and music will reference the day trains began running forever. It will mark a turning point as significant as the arrival of the first railways themselves. The symbolic power cannot be overstated. Africa has often been portrayed as the last to adopt technology. Now it is the first to lead. That reversal challenges stereotypes, reshapes narratives, and ignites new confidence. Investors notice. Foreign companies begin seeking partnerships, eager to adapt the system for their own markets. Some hope to buy the technology outright, while others look for licensing agreements, but African leaders caution against repeating past mistakes. Too often, African inventions and resources were exploited by outside powers. This time, many argue Africa must retain ownership of its breakthrough. Negotiations grow tense as patents, trade deals, and political interests collide. But behind the noise, the trains keep running. Every successful journey reinforces that the system is real, reliable, and ready for deployment. In villages, towns, and cities, people celebrate each new line powered by self-sustaining energy. Markets grow, industries expand, and hope spreads. For once, the continent's story is not of aid dependency, but of technological leadership, and the rest of the world watches, realizing Africa may have cracked the code to the future of transportation. The story of Africa's first self-powered train is not just about technology, but about the vision of what railways can become. Imagine entire supply chains running without the interruption of fuel shortages. Imagine mines in Zambia transporting copper to ports in Tanzania with zero diesel trucks involved. Imagine Nigeria linking its industrial centers with northern towns without paying billions in subsidies for fuel. Every scenario paints the same picture, a continent freed from one of its heaviest economic burdens. Energy independence through trains is not merely a technical breakthrough, it is an act of liberation. For decades, African economies have been hostage to global fuel prices. When oil prices rose, budgets collapsed, inflation soared, and development plans were delayed. With self-powered trains, that vulnerability begins to fade. Trains that run forever do not care about geopolitical disputes or oil embargoes. They run as long as their wheels turn, as long as the tracks are laid, and as long as the coils keep recycling energy. The consistency they promise is more valuable than gold. For logistics managers, this means predictability. For farmers, it means crops will reach markets without sudden cost increases. For governments, it means transport budgets can be forecasted without fear of price shocks. This stability strengthens national planning and international trade. Suddenly, Africa looks not like a weak link in global supply chains, but as a model of resilience. Other nations begin to ask whether they, too, can adopt the technology. China, with its massive rail network, calculates the savings of replacing diesel locomotives. India, where rail is lifeblood for passengers and goods, examines how quickly the system can be deployed. Europe debates whether electrified high-speed lines could also benefit from onboard self-sustaining systems. The United States, still heavily reliant on diesel freight trains, sees the potential to slash costs and emissions simultaneously. Every continent feels the pull of Africa's new railway revolution. But Africa holds the advantage of being first. The patents, the manufacturing, and the expertise reside there. For once, Africa is not the buyer, it is the seller. This reversal redefines global relationships. Instead of shipping raw materials abroad and importing finished technology, Africa now exports innovation. And it is innovation the whole world desperately needs. The symbolism echoes across history. Railways once symbolized colonial exploitation built to extract Africa's wealth for foreign powers. Now railways symbolize independence built to circulate Africa's wealth for its own people. The train becomes a tool of reclamation, rewriting the meaning of the very tracks laid during colonization. Each self-powered locomotive is more than a machine, it is a statement that Africa controls its own future. Communities along the new lines feel the impact directly. Where trains once passed rarely due to fuel shortages, now they run consistently. Goods arrive on time, markets flourish, and mobility increases. The psychological effect is as powerful as the material benefits. People begin to believe again in the promise of progress. They see that innovation can come from within their borders, not always imported. They feel part of a global breakthrough rather than spectators. This sense of ownership fuels further creativity. Young inventors begin experimenting with smaller versions of the coil system for motorcycles, small generators, and even boats. A wave of grassroots innovation spreads across Africa. The train, by proving the impossible possible, unlocks imagination across sectors.
Education shifts as schools introduce lessons about RF technology, energy recycling, and African inventors. Children grow up not just studying Newton and Tesla but also Chikumbutso. Their heroes are no longer distant figures in foreign textbooks but African engineers who transform daily life. This cultural shift carries long-term power. When children grow up seeing themselves as innovators, the cycle of dependency breaks. The next breakthroughs become easier, faster, and more widely embraced. The train plants a seed of self-belief in an entire generation. Meanwhile, the global debate intensifies. Scientists in Europe attempt to replicate the system in labs, trying to understand the physics behind the endless power flow. Some succeed partially, confirming the principles, but struggling to match Maxwell's efficiency. Others insist the technology cannot work at scale, yet evidence from Africa keeps contradicting them. Every running train is a living argument against skepticism, and the more they run, the harder it is to deny. Still, the resistance is fierce. Oil companies fear massive losses if diesel consumption plummets. Investors in electrification infrastructure worry about stranded assets. Manufacturers of traditional locomotives risk losing entire markets. Lobbying campaigns launch quietly, aimed at discrediting the train. Media outlets receive funding to paint the system as unproven. Think tanks release papers questioning its validity. But none of this changes the lived reality on the ground. Trains run, people travel, goods move, and economies benefit. The truth rides the tracks every day. It becomes harder for propaganda to compete with lived experience. In time, even doubters begin to accept what they once denied. For Africa, the stakes go beyond economics. By pioneering self-powered trains, the continent positions itself as a leader in climate solutions. At international climate conferences, African delegates speak with new authority. They are not just asking for funding, they are offering technology. This changes the power dynamic entirely. Africa is no longer framed as a victim of climate change, but as a leader in the fight against it. The narrative shifts from helplessness to leadership. That shift reshapes global respect. Nations that once lectured Africa now look to it for guidance. Partnerships form not from charity, but from necessity. This new respect strengthens Africa's position in global negotiations. It also boosts continental unity. The dream of a continental railway linking Cairo to Cape Town gains fresh momentum. Other regional projects, from East Africa's railway hub to West Africa's coastal line, become viable. Integration deepens as rail unites economies and cultures. This integration reinforces peace. Nations trading and traveling together find less reason for conflict. Railways become not just economic arteries, but political bonds. The self-powered train thus contributes indirectly to stability. A peaceful, integrated Africa gains more influence globally. The innovation extends beyond Africa. Latin American nations with rugged terrains and expensive fuel imports show interest. Southeast Asian countries reliant on diesel for rural railways explore partnerships. Even Europe, proud of its electrified networks, considers hybrid adoption to reduce grid reliance. The United States, with vast freight distances, begins testing prototypes.
one by one, nations explore the system. The possibility of replacing 1.3 million diesel locomotives worldwide begins to look real. The scale of transformation is almost unimaginable. Entire fuel supply chains, refineries, pipelines, tankers lose relevance. Ports previously clogged with fuel imports shift toward cargo and trade. Pollution levels fall dramatically as diesel engines disappear. Rail becomes the cleanest and most efficient transport system on Earth. The world witnesses Africa's gift, a technology that saves money, lives, and the planet. The journey was never easy, and it is still not complete. But every train that runs proves that the future has arrived.